we go. So basically the digitalis, there's two addresses we want to watch. There's an auction address and there's a DNS reference address. So setting aside the DNS part for the moment, we're going to come back to this one. I thought we could focus on the auction part first. And the way the validators work is we have an auction address that handles everything from the moment a token is first minted to the moment the token is claimable by whoever reveals the highest bid. And the way we do this is we place two types of UTXOs at the auction address. When a digitalis token is first minted, it initializes an auction UTXO. And that auction UTXO is static until the end of the bidding window. There's nothing that can change it until the end of the bidding window. We'll come back to that idea in just a second. Once there is a UTXO for holding the actual digitalis token and the auction is underway, people can place additional bids until the end of the bidding window. And those get a unique token. And this allows us to identify bid UTXOs. So we have two policy IDs to watch for. One is the actual digitalis token that's going to end up owned in somebody's wallet. And the other is this temporary bid token that represents a secret bid that somebody might reveal during the revealing window. And we want to index all of that. So I was thinking, basically this is what we understand already. What we want to do is set up Adder to watch an auction address, filter the results we get from there into auction and bid UTXOs, parse the datum so that we can serve it via some API. And the result might look something like this. If I have a domain like hello.ada, this is what we need to know about the auction in order for the front end to work. And then any given auction might have a list of bids. I'm not yet talking about what happens after the bidding window closes. We'll come back to that. But just for this first part, all right, tracking what we need during the bidding window. Does anybody have questions about what I've shared so far?
It's good.
So these are my questions for you guys. So one, I don't know which data source is best. So Chris, when you're setting up, like if we're going to use Adder to build this, Adder gives us a few options for, whether we're syncing to a local node or a remote node. What would you use if you were building this from scratch right now to get the data from the chain?
Yeah, so I mean, you're talking about trying to resolve inputs, right?
Yes. When you say input, you mean a transaction?
Yeah. Okay. So on any given transaction, right, on the inputs, the only thing that you're going to get is the hash and the number, right?
Right.
You're not actually going to get any of the data from an input. So is that what you mean by inputs here, or
No,
are you
I
just
mean, I should say
generically?
data. Yeah, I want to be able to, eventually my goal is to be able to get the datum attached to each
Okay,
of
then yeah,
these.
then adder, with chain sync.
Right. So Adder and use chain sync
Input. Yeah, which is, it's the only one, but yeah.
Yeah, okay. And chain syncing to which node? Like
Ah,
a
so
local one or
um, I mean that's really up to us. It doesn't matter is the answer, right? Like, because if we have adder, it can be either. It can be,
right.
it can be a local node, it can be a remote node, it can be node to node or node to client. It's all of that is just configuration.
Right. Well, but that's what I'm saying. Given that we can configure it any of those ways, what would you use for a use case like this?
So CDNSD, right, uses just the public IOHK nodes over
Mhm.
node to node. So I would see no reason to not do the same unless we find, because at this point we don't need a node anywhere in our infrastructure,
Right.
right?
Right.
So if we find that we need a node in our infrastructure for other reasons, like let's say we need DB sync or whatever, right? Like something
Yeah.
that requires it, then we can revisit this. But I think that this is fine for right now, right?
Perfect. Okay. And that's what I was trying to get at. Like that's a perfect answer. And that's an answer that we can also incorporate into the course. Hey, look, there's always these public nodes available, at least to date and for the foreseeable. So we use those to start. And then if you ever hit a point where you need more than that, it's easy to change, but it's always a reasonable place to start here.
Right.
Yeah. Okay. Cool. And so thanks. I'm asking this both for like
So here's what
accomplishment.
I would say would be what we would put into the course
Yeah.
to do this
Yeah.
is our recommendation, right? Just say recommendation is to make this stuff configurable in your application using adder,
Yes. Yes, exactly.
because adder already does it. Like adder already supports it. You might as well make it configurable in your app, and this is what we recommend so that your app is now more easily portable, right? Like, you know what I mean? It's now just config to move from one node to another, to move from node to node to node to client or whatever, right? So
Excellent. I like that. And so we can show, hey, these are the options we recommend starting here. And here are some patterns you can use to easily change this config. We want you to be able to upgrade your application by changing a line or two later on. And so this is what we recommend. Okay. So we start here. That's beautiful. Now, given that once we are watching for transactions, and I don't know if anybody has an opinion here, but I just wanted to ask, is it better to first filter by the single address of this auction validator and then subdivide the results by policy ID? Or is it better just to filter by each of those two policy IDs? Or does that question make sense, or does it not matter, or do we need more info?
yeah, give me just 1 second. I'm just taking a peek here. Where does that go? Does that break out of? It doesn't. Okay. Okay. I was actually looking at the code here real quick, and the answer ends up being it does not actually matter
Yeah.
because we process all of the filters. And looking at this, there's nothing that causes it to skip the next filter.
Okay.
So it will run through all of them either way. So like when it comes to the adder filtering, I would only in this case filter it like to I would filter to transactions,
Mhm.
right? Because we don't need blocks.
Right.
But you do need rollbacks.
Mhm.
So you need to filter to transaction and rollbacks, is what I'm saying. So yeah.
And then filter those transactions. Filter, yeah.
I would
So
filter to address and datum.
yeah,
I mean,
those
sorry, so first you filter to transactions and rollbacks, right? And then within that, you're going to transfer or filter to
addresses,
addresses.
address. Yeah,
Address, yeah. If you only actually care about those tokens, you can filter to policy ID.
right. Yeah, and this is where, okay, so but effectively it really doesn't matter. I could just as easily watch just the validator address or just the policy IDs. I think watching the address feels really efficient to me. And then
Yeah.
say, okay, given these transactions at this address, now we can just, we can handle that data as we go. And we
Yes,
want
but
to,
since we know that we want the datum only out of things that match the policy ID,
Mhm.
right? Like I could just send a random transaction to the validator address, to the auction address with a datum that is bullshit, right?
Right, right, right.
And so to filter for that, that's where the policy, like filtering for the policy ID
Yeah,
also. So if you
yeah,
do both, I mean, the thing is they are and filters, right? So it has to match both. So this way, now later downstream, you need to do less data validation,
yes, yes.
right?
Okay,
Because the data validation has been done by the smart contract and the minting policy and the right, you know what I'm
right,
saying? So like it
exactly,
is, there is no way someone can get a transaction on the right address with the right policy ID, right? Like it's impossible, except
exactly.
for the people that have that key. So it means that we can trust that data a little bit more, right?
So
Because
yeah,
it's pre-validated by our validator.
exactly, exactly. The validators are built in such a way that once we filter by address and policy ID, we have a certain level of assurance that, okay, this UTXO is valid.
Yes.
Okay,
Yes. It conforms to the requirements of the validator.
okay. So
It
we're
has
going to
been,
build an
but I mean,
and filter.
right. But I mean, we do know certain things, right? Like, especially if the, datum is coming out of an asset, which it is, right?
Right.
Then we know that we minted it.
Yes, yes.
So,
Okay, so now I have a transaction that I have some degree of confidence,
yep.
includes a UTXO that matters to me. How do I get to the point of now reading that datum and turning it into something that I'd want to simply consume from the API endpoint?
Yeah. So honestly, in this case, your best answer is just gonna be look at CDSD.
Yeah, okay,
Okay.
okay.
I mean, like that's
Yeah,
what we're doing, right?
yeah, yeah,
And
yeah.
so what ends up happening is once you're done with the filter, you end up with an event, right? And
Yeah.
so for every event, you're gonna want to you process each event, right?
Mhm,
And so, the first thing that you could do is you could process the event and look at it and see which policy ID it matches,
mhm,
right? And then feed that into your next handler, right? Essentially. So you'd have a handler for each of your datum types, right?
mhm, mhm, mhm.
So, you basically have the first handler, and then the first handler just figures out which downstream handler to pass it to. That's really all it does.
And then in that handler, what libraries should we use to actually like read the the seaboard datum string and turn it into something
Goroboros.
useful? That's Goroboros. Okay.
Yep. Yep. And you'll see again, you'll see us doing that in CD and SD. So one of the things that we do, and this might be something that might make sense for us to do, is we have a Cardano models
Mhm,
repository that is nothing but data structures.
mhm,
And so we have the datum format for our DNS already in there. It's used by CD and SD.
mhm.
And so I would say that, we put it there. right? So it can be reused.
And say that one more time. What's the name of that library?
Cardano models.
Yes. Yeah. And that's a Blink Labs repo?
Of course it is.
Yeah. Okay, I'll find that in just a sec.
Yeah,
Okay.
yeah. So again, you'll see. I mean, if you're looking at CDNSD as an example, you'll see that we have a model explicitly for the CDNSD data structure for that datum, right? For the DNS datum.
Let's look at that. Okay, so in
Internal. No,
inter
it's never going to be in the command. Command is just going to be
yeah, right.
yeah.
And
Uh,
then
so it's probably an indexer. See, look, so keep going. So you'll see we have like this domain. Look, like so you'll even see we have some of these ideas here of the domain. But
yeah,
keep
yes.
wait, scroll back to the top. It's easier for me to just tell. You'll see it'll have Cardano models.
There
Yeah,
it
so
is.
it's okay. So models. So now you can just look for models. It's in here. You can see where we use it. Just yeah. Boink. So that's it. And then you see we decode directly our datum seaboard directly into it.
Use your handler. We look at
So this
the
is our handler, right? So the only difference that you would basically have is you would figure out which datum type it is, right? But what we do, you can see here for each output, if it's not nil, we try to decode it. And because we have a model that you can go to that Cardano DNS domain model, right? If it tries to decode, it'll try to match it. And you can see we actually have like, if it doesn't decode correctly, we skip it, right? Which is stop TX processing if we can't parse the datum. If it doesn't match, right? Like we throw it away immediately right there. And that's how we skip outputs that don't have the datums or whatever.
right. So this puts another validation on the data, essentially.
Yes, because it has to match now the type, that has been statically defined in Go.
Yes. Okay.
So if you want to
I
go
haven't
real
done
quick,
this yet, playing with the datum like this. This is awesome.
yeah. So if you go take a look at Cardano models, it might be a
Mhm.
good place to look real quick. Yeah, and then look at CDNS.
Oh, it's right there. Okay.
So this is a Cardano DNS domain, right? We know that it's a CBOR. We're treating it. All the CBOR stuff is always like an array, right? So that's why we have this CBOR struct as array that we use pretty much everywhere. And then you can see that it matches what our yeah, you can see that it matches what our format looks like for the datum, right? We have our origins byte array. We have a list of Cardano DNS domain records,
Right on.
or
Right.
right, this additional data is possible too, right? And you
Okay.
can see we've got how to convert it to a string, all of this sort of stuff is directly in here, and that makes it usable by anybody else too, right? So
So the DNS indexer is already done.
yeah, yeah.
Look at this, and yeah, I'll look at the CDNSD example.
Yep. So now here's the thing. If you find that you actually need to index the exact same data as CDNSD does,
Mhm.
we can give you solutions for that.
Cool.
I can,
Yeah, I don't
well,
imagine
no,
you
so
needing to do
right
it
now, well,
separately.
no, I mean, right now, CDNSD's indexer is in internal, right? Like you just went and took a look at it and I showed you it was under internal. But the point is if you
Right.
actually are using it and want to use it, we can move it out of internal and make it a publicly available package. So now you could just grab the DNS indexer directly out of CDNSD and just use that.
Yes.
Right.
Yes.
So
And soon enough, we do just want that deployed somewhere so that
well,
we
it's already deployed.
okay, right.
Remember, we already have it ready and deployed. So the question is do you actually need to index those DNS domains yourself or not?
I don't think so. I don't think so.
Yeah. So anyway, we can
Yeah.
move on.
But that's good. And because we're using them in the wallet owner's dashboard. They connect their wallet. We look for the given domain policy ID in their wallet, which will eventually be a list of policy
Right,
IDs for each top level domain.
right.
And then we want exactly this data right here when they look at their dashboard. So we really want the ability to now filter this data, or where is it? I'm in Cardano models. Where can I look to see how we would get an individual domain? I hold the token for hello.ada. What's my pathway to getting the indexed data from the DNS reference for that token?
By indexing the DNS, doing the exact same thing CDNSD does.
I look at this result. This is giving me every,
Right. So the main thing with our event handler here is we are explicitly writing DNS zones. Right. So you wouldn't be able to directly use this. Instead, you would, like we would have we would end up pulling out some of this code and, looking through it. So like you see, we're filtering by the right policy IDs, like all of that sort of stuff. So we would basically need to do the same thing. The main thing is do we really want? Yeah, I guess. Yeah. So I mean, we get that data out of the. Yeah, we should have the DNS indexer too. Yeah, I guess that makes sense. So anyway, all of this is going to be writing to like a database or something somewhere.
right,
Right.
right,
Yeah.
right. And that was the last question, really. Okay, this is awesome. So we can use CDNSD as a model. We can build this example pretty quickly and start to play around with it. And I'll be ready either to demo this or troubleshoot it at this time next week, depending on how it goes. But I'll move quickly on this. And I've done this before. I just had to shake off some cobwebs. So thank you.
Yeah.
The datum part is new to me, so I can learn that from CDNSD, and I'll be taking notes every step of the way for the course. So that gives us something really nice. Then we can talk about next week or on Thursday if there's anything additional we would want to expose from here, or if we just want to use CDNSD directly. But this question can be on hold for at least a couple days.
Right. Right.
Okay, so yeah, last question is, like, obviously storing the data locally for testing is trivial. What database are you currently using for CDNSD, or what would you recommend for storing the results for this indexer that we're talking about?
Uh,
We're using Badger, but if you want any sort of rich data, something like SQLite or even a more traditional database like MySQL or Postgres is going to make a lot more sense.
And what are the drawbacks to Badger in that case?
Badger is a very low level key value database. That's it. There's no structure, there's no helpers. It's just basic transactions, get, put, set keys, and arbitrary data. So
yeah.
it does very little for.
It doesn't do much, which is actually the reason why we've chosen it, is
Right.
to be very specific about what we're looking for. For something like this, I think the right answer is to go with a traditional database of some kind, because we're going to want to query this from random places and things,
Correct.
right? Like This is where the big difference between like the digitalis indexer and CDNSD comes in.
Yeah.
The only way anyone queries CDNSD is by doing DNS requests. This data, right? Like we're going to have dashboards and websites and graphs. And I mean, you know what I mean? Like any of this kind of like information might be stuff that we want to glean from this data. So we don't necessarily know exactly what relations we need ahead of time, which would
Right.
be the reason for using a relational database is we're able to make those relations at query time, right? By formulating our SQL however we want. We can join tables. We can, you know what I'm saying, right? Like you can choose your columns. With a key value store, you don't get any of that. So
Right.
it's very, very rigid in the design, which is fine for a lot of, you know, for the specific use cases, like for CDNSD, it works great. You know, for the other cases where we have it, where we know what we're storing, you know what I mean? Like, and it's a very specific data type. In our case, we already have more than one data type.
Right.
Right. So what would our key look like?
Brilliant. No, that's a great answer. That's the best I've understood Badger so far. Okay, thank you.
Yeah. So I mean, it makes perfect sense. You know, like when we're using, so we use Badger in CDNSD and in Bluefin. And you know, in one, we're just storing UTXOs. In the other, we're literally storing the results we've already parsed out of the datums from the UTXOs. And that's the only thing that we're storing. Right. So it's finalized data and we know exactly what it is, so we can easily key it. You know, for this, where you have, like I said, more than one data type, you know, I would see each of those mapping to a table.
Right.
Right.
Good.
Yeah. So,
Good. Okay.
so yeah, probably just go with like Postgres or something.
And that's like for initially spinning something up and quickly testing. It's so easy to start with SQLite, and then that's an
Yes, and that's
easy.
what I would. Yeah. I would do that, and then we can always graduate it to Postgres, because the nice thing is if you're using, you know, SQLite and Go, you're using the database SQL interface,
Right,
right? Which is what
exactly.
freaking everything uses. So it's not too hard to swap out, is basically my point.
Right, exactly. And so if I build this and I get the basic functionality working locally with SQLite, that'll allow me to say, okay, this is getting and serving the right data. And then
Correct.
we can come back, and can I lean on you to just help me understand how to migrate it over to a more robust database? And because I'm
Oh
really I'm not
yeah.
experienced with deploying quite like that.
Yeah, I mean those will be, that'll be easy enough. The biggest thing will be, you know, some of the interesting caveats that we've had to deal with. That currently I would say what our best handling of this is in Bluefin.
Mhm.
Uh,
Which caveats? So many caveats.
rollbacks, rollbacks.
Right, right, right,
Yes.
right.
Yeah, so in Bluefin, and we've been working with this, you know, just most recently, which is the reason why is you know, start with just, you know, figuring out where to store stuff. But like we found that we needed like additional information when we stored things that we weren't storing before, which also might be something that would be a little easier in a relational database. Um,
Yes. Much easier in a relational
yeah,
database.
like
Yeah.
when we store a UTXO, you need to know when we got it, right? Like what was the block hash and slot and that stuff from it. And the reason is on a rollback, you need to undo that data and those data
Right,
changes,
exactly.
right? So you need to track which data you need to undo.
Right, right.
So we will definitely, you know, like help out with that when you get there. So like at this point, ignore rollbacks is what I would say.
Right.
Is
Cool.
don't worry about them. The likelihood of a rollback hitting us on this in testing is
Right,
fairly small because our write rate is so small, right?
right, right.
We're only making changes, you know, 2 or 3 domain entries, you know, every so often, right? You know what I mean? It's we can hand wave it away for now,
We can
knowing,
get the thing working, and we know that there's a couple of other things we'll want to pay attention to as we
yeah,
move
to
to production.
productionalize it.
Yeah. Excellent. Excellent. Well, that's awesome. I'm pumped about this because it hits both Digitalis and the course at the same time. So this feels like a really good spot to be. And thanks. I know you repeated a few things for me that we probably talked about weeks ago, but it's nice to kind of shake some cobwebs off. And
Oh yeah, not a problem at all. And then probably we got a number 6, which is how do we deploy it?
yes.
Because we do want to cover, right? Like we want to in the PBL make sure people can deploy stuff too, right? Like all the way to, like how do I make it work? How do I make it run? Not just how do I write it. So
And then when it comes to deployment, now we have a working transaction backend. So that we'll deploy that, and then we'll have this auctions indexer, and then we'll have whatever we do for the CDNSD, or if necessary, a separate DNS indexer that serves the app. But we can, yeah, all of those things, doing that all at once I think will feel efficient, right?
yeah, absolutely. And when it comes to the storage, we can look at potentially making it so that maybe the storage is no, we're indexing it. Never mind. Yeah, we'll have to duplicate the CDNSD indexing for this database. So we can potentially look. What I was saying is we could potentially look at refactoring it, making it so that the storage for the indexer is actually pluggable in CDNSD, so that it's not Badger. But that it might really just be easier to just copy it.
Make to it, yeah.
Right.
One being for the actual serving of DNS data that makes the whole thing work. That needs to,
Right.
yeah, that's a separate level of assurance that we want versus seeing some data on the website. Obviously, we want that to be accurate, but it's not at the same level of mission critical as the domains themselves working.
Right. But I also just mean, we'll just copy it and plug in Postgres in the various places instead of trying to make the implementation in CDNSD pluggable, because CDNSD doesn't need that additional complexity. So in this case, it's a case of it's easier to copy, right, than to, make the one thing flexible. So we'll end up with 2 inflexible implementations, but that's fine. Right, like because they're for specific use cases. So
like that. Okay. So I'm trying to figure out if this is even a question. If we're running the transaction backend, which builds valid transactions to interact with this auction address, that doesn't change anything about how we would approach the actual auction indexer. Is there anything interesting about how those two things might talk to each other, or are they kept completely separate?
I think it's easy enough to keep them completely separate. And because like what you end up with is the integration point there, right? Is like actually the chain.
Right. Yeah, these
Right.
are
I mean, you'll query the indexer's data from the database for display and for those sort of things, right? But when you're actually wanting to make changes to that data, you don't ever actually write to the database. You create a transaction, and the transaction goes to the blockchain. So the blockchain is really our integration point.
Love that.
Right.
Love that.
between the two. And so that decouples them, right? So like we actually, hey, like let's get into, systems architecture, right? Like now we've got a scalable, decoupled system with things isolated to their own domain, right? And an integration point of the shared public blockchain.
I love that. That's a really fun point to get to in the course, right? Yeah, we build these two separate tools, and I hope to sound really smart someday when I say what you just said.
Yeah, I mean, and the interesting thing is we could actually draw it as a circle,
Yes.
right? You can draw the circle as the path, right? So it's like you have blockchain. We read from blockchain with indexer writes to Postgres, right? Transaction backend reads from Postgres, writes to blockchain.
Love it.
And there's your loop, right? The circle of life.
That is great. That's beautiful. All right, this gives us something to do. I'm excited to move on this, get it basically working. In the front end, we now have all of the essential transactions working, so we can move into a phase of component and UI design. Hekek and Grancho and Jesse are going to be giving a lot of feedback, and Hekek's going to be doing a lot of the work of refining the components. I'll get this spun up this week, and like I said, we'll either be able to share a successful example or what I got stuck on next Monday, and all of it informs the course. If this goes really efficiently, my goal would be to then set some dates that we can start delivering the course material. But we'll see how far we get this week, and yeah, that'll next Monday's agenda will depend on all of that. Anything else that we should think about today?
No, I think this is gonna cover a good bit.
Cool. Chris, that was fun. Thank you. And thanks everybody for being here. Yeah, feels really good to be launching into the next period of focused work. Appreciate y'all. I guess till next time then.
Until next time.
Right. Thanks everybody. Enjoy the rest of your Monday. See you soon.
Bye.